class. Today we're going to be doing something called composition of functions. It's one of the other operations of functions that we started working on earlier this week. So a composition is just when we plug a whole function into another function instead of just plugging a number in. But let's start with just plugging a number in just to get us the idea. So let's let f of x equal 3x minus 2. Now let's find f of 5. So to find f of 5, we take the 5 and we plug it into where the x is. So we're going to do 3. Now instead of x, we're going to write 5 minus 2. So 3 times 5 minus 2 is 13. So now let's do that same idea, but instead of just plugging in a number, we're going to plug in an algebraic expression. So here, let's plug x plus 7 in for the x. So we're going to do 3. Instead of writing x, we're going to write the whole thing that we're plugging in, x plus 7. And now we're going to subtract 2. We're going to continue writing this function. So all we did was we wrote f of x, but we plugged x plus 7 in where the x was. Now all we have to do is simplify. So we're going to distribute the 3. 3x plus 21 minus 2. And we're just going to simplify this to 3x plus 19. So here we have created a new function with an algebraic expression plugged in. So we could have just called x plus 7 a whole new function from the beginning. So let's try that. Instead of just calling it x plus 7, let's call it g of x. So g of x equals x plus 7. So now, f of x plus 7 could also have been written as f of g of x. That is a composition of functions. So just to be clear, f of x plus 7 equals f of g of x because x plus 7 equals g of x. So let's try to do some of these compositions if you're still a little bit confused. So here we have two new functions. We have that g of x equals 4 minus 2x, and we have that f of x equals 2x plus 1. So let's first try to find f of g of x. So here what we're doing is we're taking our function f, and we're going to be plugging g of x into it. So here g of x is 4 minus 2x. So we're just going to take that and plug that whole thing into f of x. So here, instead of f of 4 minus 2x, we're going to actually plug it into the function. So f of x equals 2x plus 1. So we're going to do 2 times this quantity g of x, 4 minus 2x plus 1. So all we have done is taken our f of x and replaced the x value with g of x. Now we just simplify, and we get 8 minus 4x plus 1. This reduces to negative 4x plus 9. So this is our composition of functions. We've created a new function. f of g of x can also be written as f of g of x. Some algebra teachers joke that we're calling it the fog because kids are often very confused by it. So now let's try this one. Now we're going to be doing it the other way. We're going to do g of f of x. So we're going to take g and we're going to be plugging the function f of x into it. Oops, that's not right. We're going to be plugging f of x into it. So here I have 2x plus 1. So now I'm going to go ahead and actually plug it into g of x. To get 4 minus 2 times 2x plus 1. I'm just going to distribute this and get 4 minus 4x minus 2. To simplify that, I just get negative 4x plus 2. Now I would like you to realize that order does matter here. Here in this example, I did f of g of x. In this example, I did g of f of x, and I did not get the same answer. So I don't get the same thing when I switch the order. Now let's try something a little bit different. In this example, I'm going to be plugging f into itself. So if I want to do my first step, I have 2x plus 1. I'm going to be plugging that into itself. So let's do f of 2x plus 1. That's the same thing as 2 times 2x plus 1 plus 1. Realize that we're taking this value and we're plugging it in for the x. So now if I distribute, I get 4x plus 2 plus 1, which is 4x plus 3. Realize that here I once again get a totally different result than I did with the other ones. Now let's try g of x. So if you recall, g of x is 4 minus 2x. So I'm going to write g of 4 minus 2x. I'm plugging g into itself. Then I get 4 minus 2, and I'm going to plug this in for the x. So I get 4 minus 8 plus 4x by just distributing this negative 2. If I simplify that, I get 4x minus 4. Once again, a different result as any of the others. Now let's try to do a similar thing, but here what we're going to do is try to do it with numbers. So let's plug numbers into the new functions that we've created. So here I have two new functions. I have g of x equals 3x plus 5, that's just a line, and h of x equals x squared. That's going to be something called a parabola, quadratic function. So now we're going to take h of x, and we're going to be plugging g of 0 into that. Well, first, let's just find what h of g of x is, and then we'll go ahead and plug 0 into our answer. So h of g of x, well, g of x is 3x plus 5. Now we're going to go ahead and plug 3x plus 5 into h. So because h is just x squared, I'm going to take 3x plus 5 and replace it where the x was. So I get 3x plus 5 squared. Now 3x plus 5 is replacing the x in this equation. Now we have to be a little bit careful about how we square 3x plus 5. You can't just distribute the square to both of those pieces. You have to write it out this way and FOIL it. If you're confused about it, think about it this way. Isn't 9 squared 9 times 9? So 3x plus 5 squared will be 3x plus 5 times 3x plus 5. So in order to multiply these, you have to FOIL 9x squared plus 15x plus 15x plus 25. This can be simplified to 9x squared plus 30x plus 25. So now that I found what h of g of x is, I want to plug 0 into that. If I plug 0 in for each of these x's, this term will reduce to 0, as will this one. My final answer will just be 25. So h of g of 0 is 25. Now, there is a shortcut to this. The other way to do this is by not first finding h of g of x. You could just start by plugging 0 into g, and then plugging that answer into h. Let's show you what I mean. So here I want to figure out what h of g of 0 is. So let's first plug 0 into g. If I plug 0 into g, I get 3 times 0 plus 5. That's just 5. I can then take that answer and plug that into h. So now that I know that g of 0 is 5, I'm going to take g of 0 and replace it with 5. So h of 5 is just this equation with the 5 plugged in. 5 squared is 25. You can do it either way. You get the same answer in the end. Whichever way you prefer, it doesn't matter to me. So now let's try one more example. So here I'm just flipping the order. So I'm going to do it both ways. One way I'm going to find what g of h of x is, then plug 2 into my answer. The other way, I'm going to just take 2, plug it into h, then plug that answer into g. So let's try the shortcut way first. So first I'm going to find h of 2. h of 2 is just going to be 2 squared, which happens to be 4. Then I'm going to take that answer and replace it with h of 2. So I'm going to find out what g of 4 is. G is 3x minus 5, so it's 3 times 4 plus 5, which is 12 plus 5 or 17. Now let's do it the other way. Here let's find out what g of h of x is. Well, I'm going to take h of x and plug it into g. So I'm going to find out what g of x squared is. Then I'm going to take the x squared and actually plug it into the x for g. So I end up with 3, where the x was, I'm replacing it with this, x squared plus 5. Then all I'm going to do is plug 2 into this equation. So here, I get 2 squared, I have to do my order of operations, is 4. I get 3 times 4 plus 5 is also 17. So either way you do it, you get that the answer is 17. Please don't forget to answer the questions.